Hello, in 2.1 we're talking about lines and angles. So the first three words we're going to talk about is a point, line, and a plane. These terms are accepted in geometry without being defined. We just need to be able to recognize them and know what they are. So a point is going to be represented by a dot, and it's represented often with a capital letter. So we'd read that as point A. Now whenever you have 2 points, so I'm going to let this be point B and then point C, we can always create a line between those 2 points. So that one's a little off, but you get the idea. Make it a little bigger. There. So we could say this would be what we call line BC, and we note it like this. The next thing we need to talk about is a ray, an angle, and a vertex. Well, the first thing is if we start with a line, we have a line here. Now I'm going to label this with a point D, a point E, and a point F. Now from this, if I create what we call a ray, meaning it starts at, I'm going to say point E, and it's a line that only goes in one direction. So as an endpoint on one end of the line and goes forever the other way. We call this a ray. So this would be a ray. And then what we can do is we can put another point on this ray. And we can label this as point G. So we could say that this is ray EG. Now we have two different kind of angles here. We have this smaller angle here. This is what we call an acute angle. So here we have an acute angle. And we can name this angle as angle, that's going to be the symbol for angle, and then you want to use the 3 letters that make of it, and the vertex has to be the middle one. So we could say GEF or FEG. So this acute angle would be angle, I'm going to say FEG. Now we also have here this angle over here. We call this an obtuse angle because it's bigger than 90 degrees. So here we have an obtuse angle, and again, we can name that the same way, either DEG or GED. So I'm going to say DEG. Again, the middle letter in your angle should always be the vertex, which is the point of it. Here's the different basic angles that we have. These you're probably familiar with from when you first started learning geometry. We know a right angle is exactly 90 degrees. A straight angle is exactly 180, which is a straight line. An acute is between 0 and 90, and an obtuse is between 90 and 180. The next thing we're going to be talking about is perpendicular and parallel lines. Well, perpendicular lines are 2 lines that intersect such that the angle between them is a right angle. So what I can do is if I go into the lower corner of this trapezoid right here, and if I draw this symbol right here, that notes that that is going to be a right angle, meaning that segment AB and segment CB make a 90-degree line. Now what we can also say is parallel lines are 2 lines in the same plane that do not intersect. So when we have this trapezoid here, we know that in all trapezoids we have one pair of parallel sides. So segment CD and segment AB would be parallel because they do not intersect. And we say assume the above figure is a right trapezoid. That tells us that that would be the right angle if it's a right trapezoid. You might also see the notation to represent parallel and perpendicular lines like this. We could say that, like I said, AB is parallel to CD, and we can say that AB is perpendicular to BC. That's the notation that you will see. Now, this picture here, you've probably seen this before in previous geometry classes. We have these 3 different kinds of angle pairs. We have corresponding angles. That means one of these angles is corresponding to one of these, meaning it's in the same place. For example, angle 1 is right here, and you can see 5 corresponds to that because it's in the same place. Example 2 and 6, and so forth. The nice thing we know about corresponding angles is they are always congruent, or they're equal. So corresponding angles are equal to each other. So that means that angle 1 is equal to angle 5. And you could give the same thing. Angle 3 is equal to, right, angle 7, and so forth. The next one we have is alternate interior. That means they're on alternate sides of the transversal. So this right here would be our transversal. They're on opposite sides of the transversal, but inside the parallel lines. We're going to assume that these two are parallel. So the inside would be 3 and 6. Those would be alternate interior. Alternate interior angles are also going to be congruent. So angle 3 is equal to angle 6. And then also, right, angle 4 is equal to angle 5. Now, alternate exterior are very similar, but instead of them being on the inside of the parallel lines, they're going to be right on the outside. So alternate, again, on opposite sides of the transversal, but on the outside. So alternate exterior would be like 1, and then the opposite side would be 8. So angle 1 is equal to angle 8, right, and angle 2 is equal to, right, angle 7. Now you will also notice when we look at this picture, we have two different kind of angles here. We have obtuse and we have acute. So I'm going to circle all of the obtuse, 1, 4, 5, and 8. All of those will be congruent with each other, whereas 2, 3, 6, and 7 are all going to be congruent to each other. Now we're going to talk about what we call vertical angles on the next page, but looking at this picture here, when we look at 2 and 3, they are going to be what we call vertical angles. Same thing with 1 and 4. They're going to be always across from each other, and they're always going to be congruent. Next page. Supplementary and complementary angles. These two words you want to make sure you know the definition to. So we want to make sure we know complementary and supplementary angles. Now, if the sum of the measures of two angles is 180, we call them right supplementary. Where if their sum is 90 degrees, then right, they're complementary. Now, to look at these pictures here below, we have an example of each. These would be supplementary because this angle here and this angle add up to 180. This is what we call complementary because this angle here and this one add up to 90. So now what we're going to look at is we can say, okay, if we wanted to find the measure of angle CBD, well, we know we have to take 180 degrees and subtract 125 degrees, and that's going to give us that missing angle measure here. Right, so when we take 180 and subtract 125, we're finding it to be 55 degrees. We would say 55 is the supplement of 125. So now here we might also see the instructions of find the complement of 60 degrees. Well, we know that means that they need to add up to 90 degrees. So if that's 60, this one has to have the measure that when added to 60, it gives us 90. Or we can think of it as 90 degrees minus 60 degrees is, right, 30 degrees. So that would be the complement of that angle. So we have the supplement and the complement. The next thing is angles between intersecting lines. So this is adjacent angles are angles that have a common vertex and a common side. So for example, this right here is going to be an adjacent angle to this one right here because they have a common vertex and a common side. Vertical angles, like we talked about in the previous page, are two lines crossed to form equal angles on opposite sides of the point of intersection, which is the common vertex, which would be like this angle here and right across from it this angle, or this angle and this angle, or even something like this and this. So now what I want you to do, I want you to pause the video and see if you can fill in all the missing angle measures in this picture right here. Okay, so we know that this is going to be 90 because if this one here is 90, this also has to be 90. If this is 90, this is 90. Well, if we know this is 90 right here and this is 30, this has to be 60. Vertical angles tells us this one has to be 60. Vertical angles also tells us since this is 30, this is also going to be 30. Okay, the last example we have here is now going to be segments of transversals. So what we're looking at here is part of the beam structure with the building is shown. The vertical beams are parallel. So these would be the vertical beams here. They're parallel with each other. From the distances between the beams that are shown, determine the distance x between the middle and the right vertical. So we want to find this distance right here. So what we're going to do is we're going to set up what we call a proportion, which is going to be a fraction that's going to be equal to another fraction. So the first thing we're going to do is start with the 6.50. And then we're going to let that over top of something else. And I'm going to go with the dimension that's right below it, which is 5.65. And then we're going to let that be equal to the next one. Well, since we don't know this one, I'm going to fill in with just the x. And again, right below the x is 7.75. Now, to solve a proportion, what we have to do is use cross multiplication. So we want to cross multiply. This is something that you have done before. So when we cross multiply, we want to start, it doesn't matter which one you start with, and we're going to multiply what we call the cross products. So 5.65 times x is just 5.65x equals, and then we have 6.50 times 7.75. So that's going to be these cross products. You can use your calculator to do this, but when we take 6.50 and we multiply by 7.75, we are left with 50.375. So we have 50.375, and we have this 5.65x. Just like we talked about in the previous unit with solving equations, we then have to now divide by 5.65. And we do that, we're getting an 8.9159 and so forth. But when we look at our sig digs here, we have 3, 3, 3. So we want 3 sig digs in our answer there. So now, with 3 sig digs, I'm just looking at my calculator, it would be 8.92, and then we're talking about, what do we have here, feet. So 8.92 feet would be the approximate distance from here to here. All right, if you have any questions on 2.1, please reach out and let me know.